Thanks for watching my video today. We are going to continue the identities of dilogarithm function, okay? Or dilogarithm is sometimes called as the spans function, okay? Okay, now this is the identity 6. Just I call it 6, okay? So we are going to prove that Li2 of negative x minus Li2 of 1 minus x plus half of Li2 of 1 minus x square is equal to negative pi square over 12 minus natural log of x times natural log of 1 plus x. Okay, this is what we are trying to prove now. So to prove this, now we are going to use the definition, okay? So Li2 of negative x is negative pi square over 12 plus the integral from x to 1 log of 1 plus u by u du. Okay, here this log is, don't get confused here, this log is just natural log, okay? Assuming that log is natural log, okay, natural logarithm. This one you can see in the integral representation for dilogarithm, okay? So Li2 of negative x is negative pi square over 12. Now I want to change this upper bound and lower bound, okay? This one, upper limit and lower limit. So it will be followed by negative, right? Negative of integral from 1 to x log 1 plus u upon u du, okay? Now Li2 of negative x is negative pi square over 12. Now this one, using the IBP integration by parts, okay? And this one is treated as first function and this is second function, okay? Negative first function log of 1 plus u into integration of second function, then is integration of du by u, which is log u from 1 to x, and from IBP it is negative, right? So this negative one and this will become positive, okay? And integral from 1 to x log u upon 1 plus u du, meaning differentiation of log 1 plus u is 1 over 1 plus u, and integration of du upon u is log u, okay? Now Li2 of negative x is negative pi square over 12. Now putting here x, so log 1 plus x into log x. If you put 1, so log 1 is 0, right? So it is 0 plus integral from 1 to x log u upon 1 plus u du, okay? Now again, using that Li2 of 1 minus x is integral from 1 to x log u upon 1 minus u du, okay? Then this one also you can get in integral representation of dilogarithm. Now using this one, these two are a bit similar, right? That's why now combining this one and this one in this, I mean we have to subtract here, right? So Li2 of negative x minus Li2 of 1 minus x is negative pi square over 12 minus log 1 plus x times log x plus integral from 1 to x log u upon 1 plus u du minus integral from 1 to x log u upon 1 minus u du, okay? We are subtracting because, why we subtract here? Because in our question it is subtract, right? It is subtracting, so we are trying to get that one. Now Li2 of negative x minus Li2 of 1 minus x is negative pi square over 12 minus log 1 plus x into log x plus, here the numerator is same, right? So log u, and the integral is also from 1 to x, right? So integral from 1 to x, combining these two, log u upon 1 plus u minus log u upon 1 minus u du, okay? Now these two you can combine it. Now Li2 of negative x minus Li2 of 1 minus x is negative pi square over 12 minus log 1 plus x times log x plus integral from 1 to x. Now taking the here LCM, okay? Taking the LCM here, so it will be 1 plus u 1 minus u, right? This will be 1 minus u log u minus 1 plus u log u, okay? Taking the LCM du, okay? Du. So Li2 of negative x minus Li2 of 1 minus x is negative pi square over 12 minus log 1 plus x times log x plus integral from 1 to x. Now multiply out there, so log u minus u log u minus log u minus u log u, right? Upon this is a plus b, a minus b, this is a square minus b square, so 1 minus u square du. So this Li2 of negative x minus allied to over minus x is negative pi square over 12 minus log 1 plus x times log x. Now here we can cancel log u, and these two are same, right? So it will be, and negative is common again, so negative integral from 1 to x, and this is nothing but 2u, right? This 2 if you plus 2u log u upon 1 minus u square du. Now substituting that u square is equal to t, so differentiate it, 2u du is dt, right? Therefore allied of negative x minus allied of 1 minus x is negative pi square over 12 minus log 1 plus x times log x minus integral from 1 to, so if you put here u equal to 1, so t will be 1, right? If you put u equal to x, so t will be x square, right? And this 2u du is nothing but dt, and log of u is nothing, if you find out here u, taking the square root both sides, then you get u is t to the square root of t, and square root of t can be represented in as t to the half, right? T power half, so log t power half upon 1 minus t dt, okay? So allied of negative x minus allied of 1 minus x is equal to negative pi square over 12 minus log 1 plus x times log x minus, okay, using the law of exponent, no, law of logarithm, law of x to the n is n log x, right? So applying here, so it will be 1 by 2 integral from 1 to x square log t upon 1 minus t dt, right? So since the meaning here, if you put here x equal to x square, right? X equal to x square, right here, x equal to x square, what do we get? Allied of 1 minus x square is integral from 1 to x square log u upon 1 minus u du. Same definition here, okay? Then what we can get, this is the thing, okay? So substituting here, allied over negative x minus allied over minus x is negative pi square over 12 minus log 1 plus x times log x minus half of, this one is nothing but allied of 1 minus x square. Now this one transferring on the left hand side, or adding both side by half of allied to 1 minus x square. Therefore you will get allied to of negative x minus allied to 1 minus x plus half of allied to of 1 minus x square is equal to negative pi square over 12 minus log 1 plus x times log x, okay? Assuming that this log is a natural logarithm, okay? Okay, this will be the proof for this identities of dilogarithm 6, okay?